Good morning. It's November 13, 2019, Math 1, solving systems using substitution. Okay, my first period class, a bunch of you are gone today, so you're watching this video. Remember, the homework is due tomorrow for you. You don't get to... First period, a bunch of them were gone. They went to Arrowhead for a tour or something. All right, what is our learning goal? Let's go with Presley.
I can use linear systems to solve real-life problems.
And Brad.
Line equations will help me understand the world around me and make predictions.
Excellent. Read me this, Greenlee.
Yes, this. You solve a system by graphing.
Yes, you solve a system by graphing. Read me this, Maddie.
So we can solve a system some other way. Oh, but can we solve a system some other way?
That's a question mark. And the answer is yes. We're going to spend the next 3 days solving systems without graphing it, using the rainbow poster for the most part. Which is awesome because imagine, hey, I've got a graph and the solution's at 3, 4. That's great. Oh, the solution's at -2, 1. That's great. Oh, the solution's at 400, -370. Do you want to graph that?
No.
No. Good answer. No, you don't want to graph that. It's off the graph. It's too big. So we need other methods. So here's our first system. We're going to solve this. We could graph this. Don't worry about the notes yet. But, oh, boom, boom. Where's x equals 3? Vertical line right there. And Liam starts at 4, 1, 2, 3, 4, and then he goes up to over 1, over 1.
Okay.
I could do that, right? Don't want to do that. We're going to solve this system. Solve. X equals 3. Y equals 2x plus 4. We're about to solve that system without graphing it. We're going to find out where those lines cross. Okay. Any ideas? Greenlee. Maybe a table. But no, I'm not going to do a table. Okay? But that was an idea that was a reasonable idea. More reasonable than buy a pet monkey, which would not be reasonable. Mr. Fisher?
Maybe like combine the equations and make one simple one.
So that actually is kind of what we're about to do. Chris, did you have an idea? Okay, look at this. What does x equal?
3.
Okay, ready? What does x equal?
Wait, no.
It doesn't change. If x equals 3, x equals 3. So what I'm going to do is I'm going to take this 3 right here, and I'm going to plug it in. I recommend you drawing that little circle and an arrow. That's kind of visually showing you what's going on. So I have now y equals 2x, but what is x?
3.
So I have 2 times 3 plus 4, so y equals 10. Yes, so where do these lines meet? 3, 10. The solution is x, y, which is really pretty close to whatever I just did over here. This is called the substitution method. Because what I'm doing is I'm taking out the x and I'm putting in a 3 instead. Because I know that x is 3. I'm going to do a 5-second count for questions.
What if instead of an x equals 3, like a y?
If it was a y equals 3, I would put it in for y, and then I would solve it for x. If I could put a number here and I could figure out what the x is. All right. Next piece. We're going to look at the transitive property.
What?
Transitive property.
I think it's like,
Transitive property. Works like this. Let's say that Nico and Gavin are the same age. Let's say that Nico and Bradley are the same age. What can you tell me about Bradley and Gavin? They're the same age. How about this? I've got $1. You've got 4 quarters. Is that cool? We're the same.
yeah.
You've got 10 dimes and I've got $1. We're the same. Is 10 quarters, or excuse me, 10 dimes and 4 quarters the same?
Yes.
This is the transitive property. Another example. This is a true example. I had a friend named Jerry. Still have him. Well, I still have him as a friend. I'm friends with Jerry. Jerry goes off to college and becomes friends with Greg. So I'm Jerry's friend. Greg's Jerry's friend. Jerry's friend. Eventually, since we were all kind of kept hanging out together, I became friends with Greg. Transitive property. We don't even need Jerry anymore. And actually now I see Greg more than, Jerry probably hasn't seen him in 20 years. Every once in a while I go and see Greg. He lives out in Arizona. He's a math teacher. But so can you imagine that? That's the transitive property. You can actually get that middle person out of the game. We don't even need him anymore. I've got $1, you got 4 quarters. I got $1, you got 10 dimes. You don't even need me. 10 dimes, 4 quarters. Okay, that's transitive property. Here's what it looks like. If A equals B, and A equals C, then, ready? We don't even need the A anymore, do we? Let's get rid of the A. What can you tell me about B and C? That's the transitive property right there. We just get that middle person out of the game altogether. Right? We don't even need you. If, boom, right, we take you out. So what does this look like, mathematical question?
So, what do you mean? So, the middle person for this equals C?
Is the A. If A equals B, and A is also C, then I don't even need the A. I know that B can equal C.
Wait. But wouldn't you need to know that to know
Well,
that?
I do know it, but, so I need it initially. I need that A there initially. So it's like this. I'm going to go back to the friendship thing. Okay. You're friends with Lizette. Lizette is friends with Jordan. Everybody's hanging out together. Do you need Lizette there to be friends with Jordan? No. Eventually, you can just be friends without. Lizette can be the person that brings everybody together, but eventually, Lizette can just step out and you can be friends with people. You don't need Lizette. If you're the same age as Lizette, and Lizette is the same age as Jordan, what can you tell me about you and Jordan? You're the same age. If you're the 10 quarters, if you're the 4 quarters, if you're the $1, and you're the 10 dimes, are we all the same? Do I even need the $1 anymore? No, they're all the same, yes. No. No. You're okay right now. Just close it and go on with what's going on here. So what does this look like in terms of a linear system? And I know this is a stretch for some of your brains, okay? I get it. Your brains are little. You're still growing. Okay, I know. And it's only going to get more complex in the future.
Oh, fine.
So here's our system that we're about to solve. y equals 2x plus 4. Y equals x minus 2. $1 equals 4 quarters. $1 equals 10 dimes. So what can you tell me about the dimes and quarters? They equal each other. So what's going on here? If y equals this and y equals this equals this. Yes.
Yeah, so you join them together.
I would join them together and I'd get rid of the y. And that's what I'm about to do. So I'm going to write down 2x plus 4 equals x minus 2. I use the transitive property to join the two equations. Since they both equal y, they equal each other. Okay. I'm going to count to 10. You guys catch up with me on the notes. We're now going to solve this equation using the rainbow posters. There are 4 ways to start this equation. Tell me away. Aiden.
I would like to subtract both sides by 4.
Subtract 4 from both sides. That's 1 entry point. Absolutely. Give me another way to start it. I'm going to put a dot here because he took that one off the board. What could you do?
I would like to add 2 to both sides.
Add 2 to both sides. That's one way to enter the problem. Beautiful. Jackson.
Divide 2 both, divide both sides by 2. Like the x.
No. Not a good entry point for the question, for the problem. I'm telling you there are 4 entry points for this problem. I put dots under 2 of them. Go for it.
I would like to subtract x from both sides.
Minus x minus x.
And then do that to
No, let's get somebody else. You've got it. Somebody else should catch up with what's happening though. Jordan?
I would like to subtract 2 from both sides.
No?
I mean, 2x.
Subtract 2x from both sides, minus 2x minus 2x.
Yeah.
Okay, those are the 4 entry points. I don't care which one we use. You guys tell me which one. Maddie, which one?
4.
Maddie starts it. Tell me what to do, rainbow poster.
I would like to subtract 4 from both sides.
Okay, minus 4. Minus 4. Nico, what is this?
The red marker of death and destruction.
Red marker of death and destruction. Destroying right there. Destroy, destroy. What am I left with, Micah?
You're left with 2x equals,
Motion sensor.
I'm left with 2x equals.
x minus 6.
Good. I should have more O's. I have JJ. Tell me what to do now.
I would like, wait, hold on. I'd like to subtract 2x from both sides.
Okay, if I subtract 2x over here, you're going to be left with a 0. You want to be left with a 0?
Oh, shoot, no, I'd like to subtract x from both sides.
Subtracting x from both sides. Minus x. Red marker of death and destruction. What am I left with, Presley?
X equals -6.
X equals -6.
Hey, wait, what?
Isn't that what I'm left with?
Oh, yeah.
2x minus 1x is 1x. Good. And I'm done with the problem. No, I'm not done with the problem. How done am I?
So now you have to add the x into the equations to find y.
I have the x, I still have to get the y. Here's how I'm going to get it. I'm going to take this x. Oh, x equals 3. I can plug it in here and I can get the y. X equals -6. I can plug it in here and get the y. Or I can plug it in here and get the y. I'm going to show you that it works both ways. What's 2 times -6? Plus 4?
Negative 8.
-8. What's -6 minus 2?
Negative 8.
-8. Doesn't matter. But let's, for this example, let's take this arrow. We're going to plug it in right there. And that's going to give us y equals 2 times -6 plus 4, so y equals -8. Put it together for me. Who can be the point builder? Trent, can you point build? Build the point. You have all the pieces for a point.
Oh, yeah. So it'd be, x would be the -6. No, yeah, -6, and then y would be -8.
Okay, and what does this point mean in the context of the problem? What does that mean, Greenlee?
It's where the two lines cross.
It's where the two lines cross. These are two liams. No, yeah. They cross somewhere. They cross at -6, -8. That's what you just found. You want to graph it. I probably do graph it for you, don't I? Okay, let's see what I do in my notes. I set them equal to each other using the transitive property, y equals y. Then I did a bunch of rainbow poster to it. Rainbow poster. Got down to x equals -6. Only halfway there. Took that x equals -6, plugged it in up here. Doesn't matter which one. And I got y equals 2. There's my point. Y equals -8. There's my point, and that's what it looks like when you graph it. Yes.
So when we know how we got the x, does it matter which equation we plug it into?
It doesn't. So right here, the -6. 2 times -6 plus 4. -8. -6 minus 2, -8. Does not matter which one. Take the easier one, if there's an easy one. Other questions before I keep going? Okay. Questions? We're not done yet. Not done. No, I'm just trying to hit you. That's what I'm actually trying to do. I'm actively trying to hit you with the cord. All right. We're not going to do whiteboards today because these are too... Trent, you need a hug. Because these problems are too complex for whiteboards. What we're going to do now, though, is in your notes, we're going to do another one. In your notes, I want you to write down these two equations. Just start with that. Write down the two equations, side by side like this. Flip your page over then.
Can I combine them together?
That's the next thing. Will you set them equal to each other using the transitive property and that joining value of y? So get rid of the y's and just set the two equations equal. In 10 seconds, I'm going to do it.
Can I do it for you?
You're probably too thirsty. X plus 4 equals -3x plus 12. That's the join. Here is my question. What would you like to do now? And there are 4 entry points for this. Trent says subtract 4 from both sides. Chris says, Chris wants to do what Trent wants to do. Maddie,
Subtract 12 from both sides.
she wants to subtract 12 from both sides. Jackson,
Subtract X from both sides.
subtract X from both sides. Anybody else? There's one left. Jordan,
Add 3x. I mean, yeah, add 3x.
add 3X to both sides. I don't know what to do. Bradley, you decide.
Subtract 4 from both sides.
Bradley says subtract 4 from both sides. Oh, you got it. Red marker of death and destruction. Taryn, what am I left with? And now we're pretty much committed. After that first step, you don't have a lot of choices going on. Greenlee, would you like to tell me what to do?
Subtract both sides by, sorry, I want to add both sides by 30x.
Fix the grammar.
I want to add negative 3x to both sides.
Add negative. By doing negative 3x,
3x.
add 3x to both sides.
Sorry.
How about that?
Like,
What does that leave me with?
4x equals 8.
And then let's talk to Gavin. What do you want to do, Gavin?
Me or him?
Gavin, the one that I'm looking at. Divide both sides by 4. So x equals, Gavin? And I'm done. No, I'm not done. What do I still have to do, Chris? Do you want to plug it in here or do you want to plug it in there? Does it matter? Which one would you plug it into, Presley? Which one would you use, Micah? Which one would you use, Chris? Are you bending to peer pressure?
Yep.
Why are they saying the first one? It is easier. It doesn't look easier?
Yes.
So let's go with it. So using an arrow, something like that, kind of show that you're plugging it in. So what's X going to be?
6.
Oh, sorry. X is 2.
Oh, so, what is Y going to be?
6.
Y is going to be 6. Trent, are you still my point builder?
Yeah.
Okay, point build.
So the x will be 2 and the y is 6 plus 2.
Greenlee, what does that point mean?
It means where the lines cross.
To where those two lines cross. They cross at 2, 6. There it is. So here's all the math for this thing. If you get stuck at home tonight, you can go back to these notes. They're pretty good. We do one more. Slide number 19. I'm going to jump over one. I don't care about that one. 19. What I want you to do is I want you to get the X and then have me check it. Once your X is good, I'll tell you to go get the Y. come by and start checking some X's, and then you're gonna go to the Y's. You got an X for me? Go to the Y. You got an X? Go to the Y. You got an X? Go get a Y. You got an X? Go get a Y. Get that Y on this side. You got an X? Go get a Y. You got an X? Go get a Y. You got an X? Where's your X? Go get a Y. Monica, do you have an X? Go get a Y. You got an X, go get a Y.
Can I start over or hold up on
You get an X? No, you gotta have me check your Y first. You have a Y? I'm not ready. You got an X? Go get your Y. You got an X? Okay. See that? Oh. You have an X, go get a Y. Okay, good, son. Go get your Y. Have me check. Actually, before you do it, show me your final answer and have me highlight it. And then you can start the homework. You got a final answer for me? Good. Good. That's good. That's cool, man. Something's off with your Y. Work together. Help him fix it. Don't just give him the answer. Help him out. Good. See that? That's a 1. You have there as a -1. So do you want to erase that negative?
Yeah. I'm very sure.
So, okay, I'm not going to highlight it yet then. Put it all together for me. Where's yours? Disagree. I disagree with that. Talk to her, see if she can help you out. You're not highlighted yet. You're highlighted. Good. Excuse me, man. Okay, you can start the homework. Hello. You done?
Wait,
What is it? You can't self-highlight, no. You're not ready.
oh, I thought you said you highlighted.
Put it on a recording plan. Start homework. Good, you're good. You get highlighted? What are you highlighted? Put together. Good. Good. Bradley. Good. Nico, you fix that up for me?
Yeah.
Call me over. Got it? Good. You get highlighter, you still working on it? It still needs my highlighter. The highlighter gives you all sorts of power. Do you get highlighted?
Yes, I did. Can I look at one?
En español. Venga aquí. Venga. Huevo. En español. Que nada. Yo bebo agua. Tú bebes agua. Ella bebe agua. Él bebe agua. Nosotros bebemos agua. That's your Spanish. Okay. Dude, I'm trying to take my Spanish up. I've been doing Spanish lessons online for the last 2 days. So you know I'm getting really good. This is what we've done. So it's ¿Cómo? No, like comer. So yo como, tú comes, usted come, and then they don't do we's in this thing, but I know it from teaching Spanish in high school. And then that would be nosotros, yeah, comemos. This is an ER verb. And I learned mujer, hombre, niña, niño, leche, agua, manzar, milk. These are just the words that have popped up in this lesson so far. Hola.
Hola.
Hombre. Boom. Hombre o niño.
I'm gonna need you over. I'm getting that Uber.
Yeah, let me stop my live stream. You good?
I'm sorry, I thought you said you highlighted, so I highlighted.
Alright. Anybody else need to highlight? Did you do the one? Right here, this is the best move. Write this down again. So, here's my scroll. Let's subtract. Happened right here, obviously. This should be a plus 4, plus 4. So it would be a negative 4. Change that for negative 4. So if you want negative 4, they would negative 4 plus 4. Negative 8 plus 4. So change this to negative plus 4. Which would be negative 4. Change that to
Mr. Barre, it's really hot in here.
It is.
It's a good thing I let you go get some water. Because I don't want you to get dehydrated. Oh, okay. I'm hanging up. I'm stopping the stream. Okay, do you guys hang up a phone?
What?
No, my parents are